Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to the website at www.arcweb.com.
Hello and welcome to this Digital Transformation podcast from ARC Advisory Group. My name is Chantel Polsonetti. I'm an analyst at ARC whose coverage areas include industrial network infrastructure and industrial edge hardware and software. For those not familiar with ARC, we're a leading global industry analyst firm with a 40-year history of covering digital transformation in industry, energy, and critical infrastructure. Now, this edition of the podcast focuses on the exciting new features inherent in the IEEE 802.11ax or Wi-Fi 6 wireless standard and Wi-Fi 6E, which enables operation in the 6 gigahertz band. My guest today is Danny Walters, Product Marketing Specialist for Wireless Products at Phoenix Contact USA. Hello, Danny, and welcome.
Thank you, Chantel, for inviting me to join.
Absolutely. So for the audience's information, Phoenix Contact is a 100-year-old, €3 billion family-owned company that markets a diverse portfolio of components and systems for machine building, control cabinet manufacturing, e-mobility, and generating, transporting, and distributing energy. The company markets over 60,000 products, such as IPCs or industrial personal computers, PLC Next controllers, and wired and wireless industrial network infrastructure that are typically applied in the control cabinet or in the field. Now, Danny himself has been with Phoenix Contact for 7 years. He has a passion for industrial automation and wireless technology, especially Wi-Fi 6 and Wi-Fi 6E. So, Danny, we know that Wi-Fi is a very popular technology in industry today. As wireless technologies advance, they offer increased reliability, performance, and security, as well as many benefits like ease of use, including implementation, plus a common knowledge base. However, we know the hard way that this popularity leads to spectrum congestion issues that hinder its use. So in your mind, what makes Wi-Fi 6 different than previous versions of Wi-Fi?
Yeah, so Wi-Fi 6, the big difference between it and previous versions of Wi-Fi is the focus on efficiency. So instead of just trying to increase data rates and make the radios themselves more powerful or the processors inside the devices faster and able to process more data, Wi-Fi 6, they really makes an effort to make the protocol itself more efficient. There are a finite number of wireless resources, so to speak. There's only so much data and communication that you can fit over the airwaves. And I think you had mentioned,
Sure.
Congestion being an issue with Wi-Fi. And so Wi-Fi 6 really looks at, hey, how do we communicate in a way that's more efficient? How do we structure the protocol itself to be more efficient? And which then leads to the protocol being more scalable long term and a more sustainable or more scalable wireless technology going forward. So that's where, of course, Wi-Fi 6 does bring speed increases, but the real significant piece, or the real thing to emphasize, is kind of the restructuring of the protocol to make it more efficient.
So that's excellent. So can you speak to some specific technologies that Wi-Fi 6 and 6E employs that promote its efficiency?
Yeah, absolutely. So the big one that really the star of the show is something called OFDMA, which stands for orthogonal frequency division multiple access. You don't need to memorize that whole that
Right.
whole thing. Just knowing hey, OFDMA is enough. And simply put, what OFDMA does is it allows a Wi-Fi 6 access point to subdivide a Wi-Fi channel into multiple subchannels, and then use each of those subchannels to communicate to a different device. So you can have the Wi-Fi 6 access point can send out one message. Effectively, one message has got multiple parts in the message, and each part of that message is actually intended for a different client device. So previous versions of Wi-Fi relied on just OFDM, not multiple access. And what that did was it required the Wi-Fi access point to allocate an entire channel to one client device, regardless of how much data that client device needed. So roughly speaking, the more data that a Wi-Fi client needs or Wi-Fi device needs, the more of that the more channel, the more bandwidth they're going to need. So if you have a 20 megahertz wide channel and a device is only updating just some text on a web page, maybe it only uses 2 megahertz worth of that 20 megahertz channel. Effectively speaking. So the previous versions of Wi-Fi required that access point to allocate the entire 20 megahertz wide channel to that Wi-Fi device, that Wi-Fi client, even if it only needed maybe 2 megahertz worth of that 20 megahertz wide channel. And what that would do is it wasted space. It
Right.
wasted that spectrum that was available. So that's a big inefficiency, right? There's all this spectrum that could be used, but isn't being used for another device. So a helpful analogy that you can think of is if we look at semi-truck trailers, and you got trucks driving between two different locations, and you look in the back of that trailer, maybe you have just one pallet in that trailer, even though there's space for 10, 20, 30 pallets, however many pallets you can pack into a trailer. And that semi-truck trailer says, nope, I'm only going to take this one pallet of goods, even though there's other customers at my end location that I could stuff other packages, into the trailer. I'm just going to take this one pallet. That's OFDM. OFDMA says, hey, you know what? We've got a ton of space in this trailer. Let's go ahead and pack it, much more efficiently. Let's fit multiple pallets of goods into this trailer, each pallet or maybe groups of pallets going to different customers at the end location. And so that's kind of very obvious there, right? The more efficient packing of that trailer is just going to be more efficient, right? You need less trucks. It takes less back and forth trips to service the same amount of customers. You can view OFDMA kind of in a similar light as far as the impact that it has on increasing the performance of the network and what it does. So OFDMA, simply put, it increases the capacity of a Wi-Fi network, or at least has the potential to, which then can decrease latency and all sorts of good things. So.
Yeah, I really like the way that you translate the OFDMA into efficiency. And, I think your semi-truck analogy is spot on. But one of the things that we find customers are particularly interested in addition, there's a lot of things going on with Wi-Fi 6, 6E, Wi-Fi 7. But a lot of people are really excited about operation in the 6 gigahertz band. Can you speak to a little bit about the benefits of that too?
Yeah, absolutely. So traditionally Wi-Fi has relied on originally it relied on 2.4 gigahertz, the 2.4 gigahertz band, and then we rolled out the 5 gigahertz band, and we know 2.4 and 5 gigahertz today. That's kind of the traditional Wi-Fi Wi-Fi spectrum that we're all used to. And if you open up if you scan for Wi-Fi networks on your phone when you're at someone's house or out somewhere, you may notice something that says Danny's Wi-Fi 5G and Danny's Wi-Fi 2.4 or something of that nature. That's what that's referring to, right? So we've seen that, you've seen that out in public and maybe just been completely unaware of it. So we're used to 2.4 and 5 gigahertz. The 6 gigahertz band, is introduced with Wi-Fi 6E, and Wi-Fi 6E is simply Wi-Fi 6 extended, is what the E stands for. So you're extending the Wi-Fi 6 features into the 6 gigahertz band. Now the 6 gigahertz band, effectively as a clean, wide open chunk of spectrum. There's more or less nobody using it. There are incumbents that you do have to kind of contend with if you're doing some higher power and outdoor Wi-Fi, 6 gigahertz applications. But relatively speaking, inside a factory and that sort of thing, it's more or less empty. And so that is a big benefit with the 6 gigahertz band, is that with Wi-Fi, like we've talked about, congestion is a huge issue. There's just not channels available. There's too many devices, all of those things, and it causes issues. And so the 6 gigahertz band being clean and wide open, it presents a massive opportunity for just increasing performance of the Wi-Fi network overall. Furthermore, the 6 gigahertz band it's over twice the width, or has like over twice the number of channels as the 2.4 and 5 gigahertz bands combined. So it's a pretty massive increase as far as the space that you have to use. It's a wide new highway, so to speak.
So let's speak to that for a second, because, as you mentioned, we progressed from 2.4 to 5. And we know that when the 5 gigahertz band opened up, it didn't take long for everybody to pile in, right? So congestion is obviously a big detriment to Wi-Fi performance. So how do we offset the potential for everybody just to pile into that 6 gigahertz band?
Sure. And that's a great question. So over time, yes, there are going to be more devices that are going to use that 6 gigahertz band. However, I think it's important to point out that only devices that are Wi-Fi 6E or Wi-Fi 7 are going to be allowed on that 6 gigahertz band. And the reason that's important is because Wi-Fi 6E and 7 devices utilize those new technologies like OFDMA, which we talked about. BSS coloring is another new feature that you see with Wi-Fi 6, and that refers to that helps to reduce the amount of I believe it's co-channel interference, I think is how that's phrased, between different access points that are on the same channel and client devices hearing messages from those other access points. So BSS coloring helps to distinguish between which access point is you should ignore and which one client device should pay attention to. So that does help as well. And then there's other future advancements that may come with other versions of Wi-Fi as we look to Wi-Fi 8, 9, so on and so forth. And so all of that said, those technologies I do think are going to extend the use of that 6 gigahertz band quite substantially. And so I don't think that 6 gigahertz band is going to fill up quite as nearly as quickly as some people may have concerns about.
Well, certainly another, I know you're a Phoenix Contact USA guy, but I know for our global customers that the fact that, given that it's wireless spectrum and the regulations associated with it, but the increasing number of countries that are certifying operation in the 6 gigahertz band really makes it, a potentially global technology that, international companies can adopt, right?
Yeah, absolutely. We are seeing adoption of the 6 gigahertz band outside the U.S. There are differences as far as what channels are. Other countries are opening up. In Europe, last I checked, they've not opened up nearly as many channels as we have access to in the U.S. And I believe that China, I don't think has opened up any of the 6 gigahertz band. That may have changed. But I'm pretty sure that they have not opened it up yet at all. So, but there is international, generally speaking, there is international adoption of the 6 gigahertz band.
Right. So for the audience's benefit, I just want to point out that at the end of this podcast and also on the web page summary, we're going to provide numerous resources where the audience can delve further into a lot of these technological advantages associated with Wi-Fi 6 if they want to further investigate. But another thing that I wanted to get into a little bit is, as Wi-Fi technology keeps progressing, simultaneously, particularly a couple of years ago, we had this big, let's call it the 5G hype cycle, right?
Sure.
And now we have the whole private cellular, and we do know that, of course, the bloom is off the rose, so to speak, in terms of private network implementations, and it certainly hasn't gone on the curve market adoption wise that we had anticipated. So how do you see, for customers making the decision between these increasingly capable Wi-Fi 6, 6E, and Wi-Fi 7 standards, how do they, evaluate it versus private cellular?
Sure. So private cellular is an option as well, and it does offer superior performance, and in basically every category, performance, specifically. So it's going to have better speed. It'll have lower latency. It's going to have longer range in many cases, and that has to do with being able to control, fine tune all of the parameters of the network, and having dedicated spectrum, and having licensed, in some cases licensed bands that you can license, or maybe even unlicensed if it's CBRS, that you can transmit at higher powers and different things. So it does offer superior performance. However, it can be very expensive, and there can be quite the learning curve. So Wi-Fi. Wi-Fi is very well understood. We're all familiar with Wi-Fi. IT departments are very familiar with it. But but private cellular is not the same way. IT departments, and especially consumers, we're not. Your average person is not familiar with a private cellular network and how that works, and how to manage it, and all of those things. And so those can all be barriers to entry for a private cellular network. And I think when we look at things like Wi-Fi 6E and Wi-Fi 7, which open up, which employ like OFDMA and BSS coloring, the 6 gigahertz band, even multi-link operation with the Wi-Fi 7, that performance gap begins to narrow a bit. So that choice between Wi-Fi 6E and Wi-Fi 7, and comparing that to private cellular, that does become a bit of a harder choice, I think.
Yeah. So Danny, do you perceive any diminishing returns with private cellular networks?
Yeah, I think depending on the application, there may be. So I think we need to take a step back and think about what the biggest complaint is about Wi-Fi in industrial environments, and that's going to be channel congestion and dropouts. And I think for most industrial customers, they don't need the sub-millisecond latency or multi-gigabit download speed that private 5G promises. Many industrial customers, I think, they're satisfied with the current performance of Wi-Fi, just as long as there's channels they can use and the connection is reliable. And like we mentioned before, the 6 gig OFDMA and the 6 gigahertz band, they do go a long way to helping solve those problems. And so there may be a point, or there may be some industrial customers that do in fact want or need the performance levels of private cellular offers. And for them, it's a good option to consider. But I think for anybody that's considering private cellular, they do need to ask that question, how good is good enough? And I think for many customers, Wi-Fi 6E with OFDMA and access to the 6 gigahertz band is going to be enough. It's going to be enough for them. So.
But I do know, from our experience, and like I said, now that, we've had a couple of years to actually look at the, private cellular and even public 5G, it certainly is not a trivial undertaking, right? So, we know we're finally getting some devices, that meet industrial requirements, certainly. But, the whole need for spectrum acquisition, like you said, maybe you could get a public slice, but a lot of folks are looking at private, capabilities. So, just comparing the Wi-Fi versus cellular, there's a lot of implications to that decision that once again will provide further resources on that for the audience to pursue offline. So in terms of you guys at Phoenix Contact, can you speak a little bit to what you bring to the table for customers looking at Wi-Fi 6 and 6E?
Yeah, so Phoenix Contact does have some Wi-Fi 6 and Wi-Fi 6E client devices available today. We offer them in two different form factors. We have an IP20 traditional DIN rail mounted device. Can be panel mounted, but it's got external antennas, which then gives you flexibility on where you place those antennas and the type of antennas that you use. We also have another form factor that's an IP rated form factor. It's IP66. It's got some water resistance, that sort of thing.
Sure.
And that form factor is intended to be mounted on the outside of a panel. It has integrated antennas, so that does give you some nice flexibility as far as where you mount those devices and the types of applications that you can service, especially when it comes to things like AGVs and AMRs.
Right.
Those Wi-Fi 6 products are going to be known as our FLWLAN 1121 and 1021. Those are the North American versions of our Wi-Fi products. They are currently known as they're Wi-Fi 6 clients today. They're considered soft APs, so they can act as an access point, but when it comes to the Wi-Fi 6 features, they don't quite have the processing power to serve or to act as full-fledged Wi-Fi 6 access point. So the Wi-Fi 6 features more or less get stripped out. If you put them in that mode, if they act as client devices, they're full-fledged Wi-Fi 6 devices. So you can connect them to third-party Wi-Fi 6 infrastructure.
Sure.
They're great devices for that. We do have a 6 gigahertz firmware update actually coming. It's currently slated for July. Approximately in July, via firmware update, those Wi-Fi 6 clients will actually be able to use the 6 gigahertz band. So hardware-wise, they are Wi-Fi 6E capable. So we do have a firmware update coming here in a couple months that will, I guess in 2 months, a month, give or take, that will unlock that. So we're very excited for that. We do have some international versions as well. Like with other wireless, technologies, or different countries handle their spectrum allocation differently, and so you do run into some specifics that you need to account for when you are releasing wireless products in different countries. And so, Phoenix Contact being a global company, we do kind of contend with that and have options, flexible options for different regions there. So we do have some 6 gigahertz options as well available for international use as well. So that is something to keep in mind. And then kind of rounding things out, we do have Wi-Fi 6 and 6E AP access points that are in development. The Wi-Fi 6 access points are slated for release at the end of this year, and then looking into next year, we are expected to have Wi-Fi 6E access points. So. Yeah. We are very excited for that.
So I just want to clarify, because this is a recorded podcast that we anticipate people will be listening to for a while. So the dates you cite are actually July 2025, right? And
correct.
You say, yes. So end of year, the AP availability or access point availability is end of 2025. And also, I'm subject to the same thing, but I just want to clarify for the audience, when you say AGVs, we're talking about automated guided vehicles, which are a very, very dominant use case for Wi-Fi clients, right? And you also mentioned AMRs, which I consider to be autonomous mobile robots. Is that what you were thinking of too?
Yes, correct.
Yeah. So those two use cases are, very popular for industrial Wi-Fi, and also two areas where we see a lot of customers making decisions about that private cellular versus Wi-Fi that we talked about a second ago. Sure. But I also, Danny, I wanted to give you the opportunity, in industry, as we increasingly adopt what we call COTS or commercial off-the-shelf technology, whether it's Wi-Fi, IEEE 802.11 or Ethernet, 802.3. How would you guide a customer when they're looking at buying an industrial device versus a COTS device? Like, what should a customer look for in industrial Wi-Fi devices?
Yeah, you said an industrial device versus a what device?
Like a commercial device. Like, can I just buy a commercial AP and use it in my factory?
I would say no. A big thing is going to be the ratings and approvals of that device. So that commercial device, it may work for a time, But when you look at things like IP ratings, when you look at vibration and EMC resistance, temperature ratings, maybe hazardous approvals like Class 1 Div 2, those are all going to be things that a commercial device is probably not going to stack up well against. And so if you try to use that commercial device, it may work for a time, but it probably is not going to last. And it may not have the features as well that you need for your application. So those are things to keep in mind there.
Yeah, because we find that customers will say, "Oh, I can buy this on Amazon." They put it in their factory and it fails, and the client doesn't work or something like that. And it's like, well, you got to take into consideration all those, environmental ratings and everything you mentioned. Also, industrial devices typically might have more robust antennas. Right, all kinds of features that, again, thinking about people making purchasing decisions, industrial products, are designed for our manufacturing, energy, and infrastructure environments, and certainly perform much better, and that's a caution right there. So, in terms of the company Phoenix Contact, we know you have a strategic initiative called Digital Factory Now.
Sure.
So can you explain that concept and then how your industrial wireless devices fit into that larger initiative?
Sure, absolutely. So Digital Factory Now, it's an initiative that's all about Phoenix Contact offering customers a collection of tools that help them digitally transform. So, we help customers, what that means is we help customers collect, store, analyze, and visualize their data. So there's a lot of trends in industry, a lot of new technologies out there, whether it's things like AI and ML or even IIoT, and all of these different trends and these buzzwords, they require data, and they need customer specific data to really be most beneficial for them. So these AI models, for example, they're only going to be as good as the data that you give them.
Right.
And when it comes to this data and using it, transporting that data is a big piece. You need to get it from one point to another. And wireless is a great option, is a great option for doing that. And among the wireless options out there, Wi-Fi is going to be the most popular. So Wi-Fi, this popularity can be a drawback though, because it does lead to things like congestion and like we've talked about before. But that's where the Wi-Fi 6E comes into play. So what that does is, Wi-Fi 6E basically opens up a wide new highway, an efficient highway at that the 6 gigahertz, which is what the 6 gigahertz band provides, and the 6 gigahertz band alleviates those congestion issues, or can largely alleviate those congestion issues, which then enables customers to transport that data, that key data, even better, more efficiently, back and forth. Now there is, private cellular, and you can view private cellular like a new toll road. That's even better than that new highway that was just opened, but it's a lot more expensive.
Right.
Either way, both those technologies, Wi-Fi 6E and private cellular, are just ways to transport data. And so, Wi-Fi 6E, it's one of the wireless solutions that Phoenix Contact offers customers to help them transport that data that's crucial for their digital transformation journey. And so, in a similar way, Wi-Fi 6E helps support our other initiatives, whether it's the open process automation and our focus on the our all electric society. So, open process automation, it's all about giving asset owners, access to the data in their facilities, regardless of the hardware manufacturer, that data that they need to improve their processes. And then all electric society is just about using automation to help support the move away from fossil fuels and towards an all electric world. But both of those initiatives, just like Digital Factory Now, they rely on using transporting data from one place to another. So this development of new Wi-Fi technology, new devices that for Wi-Fi, that just helps support those initiatives. So
yeah, because you and I could talk Wi-Fi all day, but I think for a customer perspective, it's great to have an organizing concept like Digital Factory Now that you're Whether it's your Wi-Fi infrastructure, your wireline infrastructure, your control products, your compute products with IPCs, that, it all falls within an organizing concept that, speaks to our customers' end objectives, right? Mm-hmm. So I think that's great. Okay, so Danny, really thank you for your informative comments and insights regarding Wi-Fi 6 and 6E in industry. I'm just curious, as we wrap up, do you have any last words for our audience?
Yeah, I would just say that Wi-Fi 6E, it brings some substantial improvements to Wi-Fi. So things like OFDMA and the 6 gigahertz band, they have the potential to massively improve the performance of Wi-Fi networks. And Phoenix Contact is committed to continuing to provide a variety of wireless solutions for different applications. The Wi-Fi 6E devices are just one of those solutions.
Excellent. Well, I'd also like to thank our audience and refer them to the resources on this podcast webpage for further investigation from both Phoenix Contact and ARC Advisory. So you'll see the link to the Phoenix Contact Wi-Fi webpage for more details on Wi-Fi 6 and 6E and links to their available industrial Wi-Fi devices. You can also find Danny Walters on LinkedIn or reach out to him at dwalters@phoenixcontact.com. So again, this is Chantal Polsonetti from ARC Advisory Group signing off for this edition of our Digital Transformation Podcast. Thank you and goodbye.